So here is a Hess's law problem, and our goal is to find out what the change in enthalpy is for 4 moles of arsenic monoxide reacting with O2 to make 2 moles of As2O3. And we're given these two equations. So as I look at them, the only one of these two constituent equations with As2O3 in it appears to be this second reaction, and 2 moles of As2O3, 2 moles of As2O3, and so this equation is going to stay the way that it is. Now when I come up here and I look at that first equation, 2 moles of arsenic plus 1 oxygen yields 2 ASOs, arsenic monoxides. Well, this guy is a product here, and that's the only place it shows up, and I need it as a reactant in my overall reaction. So this equation I am going to need to flip. So I'm going to rewrite it reversed. So 2 ASO decomposes into 2 moles of arsenic plus a mole of O2, and since I reversed it, that would mean delta H is going to be the same number, but now it's going to be negative 140 kilojoules. So then we'll scratch that guy out. Now when I look at this, I feel like we're on the right path, but notice it was 4 moles of arsenic monoxide, and here we only have 2 moles of arsenic monoxide. So what I'm going to do is I'm going to double this entire reaction. So we're going to make this a 4, this a 4, this is going to get a 2, and then this is going to double and become negative 280 kilojoules. And when we do that, I think we might be there. So let's see, there are 3 moles of O2, 2 moles of O2. So those 2 moles of O2 will cancel and leave behind just 1 mole of O2. And then we got the 4 arsenics and 4 arsenics. Here is a reactant and here is a product. So that will also cancel. And that leaves us with an overall equation, let's see, of 4 ASO plus this guy, the 1O2, yields, and the only product left standing are the 2 moles of As2O3. So that this equation matches that equation. So I can now add together the delta H's, and delta H for that overall reaction will equal 1587 plus 300 would be 1887, take back 20, so negative 1867.6 kilojoules. So there is our overall delta H for that original equation.